Okay, this is lesson 2.4. This is the last thing we're talking about in chapter 2. Okay, we're still working with quadratics. We're still working with y equals x squared. Okay, and this is just a little bit of a review from 2.1 and 2.2. If we have y equals x squared, how does this graph move? We just look right here at the end, it's plus 5, it goes up 5 units. Okay, so instead of the vertex being at 0, 0, it's just at 0, positive 5. Okay, so a little bit of review here as we move forward. Right now we are going to be mastering all of this. What is going on here? Why can I do that? I can't scroll. Come on now. Scroll for me. Okay, I got it figured out. We have this one, y equals x squared minus 7. Now we're just looking at that minus 7. How does that graph move? Goes down 7 units. Okay, and our vertex is now 0, negative 7. Okay, this next one, we have something in parentheses. And remember, when we have something in parentheses, we think opposite. So what's in those parentheses? It's plus 4. So we're going to go to the left 4 units. We're going left 4 units, so now our vertex is negative 4, 0. Okay, this one, we're going to combine the two. We have x minus 5 squared minus 3. Okay, so we look here. We think opposites, so we're going right 5, and we have minus 3, so we're going down 3. So what's our vertex from 0, 0? We go right 5 and down 3. Next, we have something out front. We have this number here, this number 4 out front. Does that change how we look for our vertex? No, it doesn't, right? That just makes it skinnier or wider, whatever that number is. We're still looking right here. We're looking in the parentheses. Okay, we think opposite inside the parentheses, so left 3. And we have minus 6, so down 6. So our vertex is negative 3, negative 6. And now we have something crazy. Y equals 0.006 times x plus 2 squared minus 1. Again, we're just looking inside the parentheses. X plus 2, so we're going left 2, minus 1, down 1. So, vertex is negative 2, negative 1. Okay? How about something really crazy? 193 over 2 times x plus 6 squared plus 11. Stick inside the parentheses. Plus 6, we're going left 6, and we're going up 11. So, what's our vertex? Negative 6, positive 11. Okay. Throughout chapter 2, this is the equation we've been working with. It's everything we've been working with, where each of these has an assignment. This, A, makes it skinnier or wider. Makes that graph skinnier or wider. What makes that graph skinnier or wider? Well, if it makes it skinnier, A is going to be greater than 1. To make it wider, A is less than 1. Okay, so if that number A is between 0 and 1, sorry, I should write that. When it's wider, that number A is between 0 and 1. Okay, between 0 and 1. This number here, we go left or right. Okay, just like we were doing in the examples. And then this over here we have plus k goes up or down. Okay, if it's plus, it goes up. If it's minus, it goes down. Back to our left and our right. To go left, it has to be a plus. To go right, it has to be a minus. Okay? So we've worked with this equation. Y equals a times x minus h squared plus k. All right, so what we have to do is we have to write an equation that has a vertex of 4, 2 and goes through this point, 7, 13. So we're going to be using that equation we just saw. Y equals a times x minus h squared plus k. Let's start with our vertex. We know our vertex. We have plus 4, so that's positive 4. So we need, did I say that right up here? Sorry. We need minus 4 in our h, right? To go right, we need minus 4, and plus 2, we need a plus 2. So we need y equals a times x minus 4 squared plus 2. Okay? And now it goes to these points, 7, 13. Remember, what's x and what's y? Well, 7 is x and 13 is y. So let's plug those points into our x and our y. So 13 equals a times 7 minus 4 squared plus 2. So here's where we're at. Now, if you were given an equation and said, what does this equation do? We'd have no clue because what's this a doing? What's this a? We're going to solve for a. That's what we're doing right now. Okay, solve for a. 7, we remember we have to use order of operations, so we have to go parentheses first. So 13 equals a. 7 minus 4, that's 3. We're going to square it, plus 2. Okay, remember we do PEMDAS, so parentheses, then exponents. So we have 13 equals a. That's times 9, plus 2. You know, I want to solve for a. So what do I have to do? If I have 9a plus 2, I'm going to subtract 2. So I'm left with 11 equals 9a. I just switched these two around. Okay? So now instead of a9, we have 9a. Then we're going to divide by 9 on both sides. And we're left with a equals 11 over 9. Okay, we solve for a. Now, we can put this into our equation. A equals 11 over 9. We can throw that back into this equation. So our final answer should be y equals 11 over 9 times x minus 4 squared plus 2. Here's our final answer. Okay? And if you were asked about this final answer, y equals 11 over 9 times x minus 4 squared plus 2, you could tell me exactly what each of these numbers mean. Okay? Let's move on. Let's try this one. We have our graph, or we have our vertex, right? Our vertex is negative 2, 6. So remember, the equation we're working with is y equals a times x minus h squared plus k. We know our vertex. We have negative 2, 6. So we went left 2, so this has to be plus 2. X plus 2 in the parentheses squared. We went up 6, so this would be plus 6. Remember, we don't know a yet. Okay. Now, I'm going to take these points that are going through. Negative 1 and 3. Where negative 1 is x and 3 is y. So, 3 equals a times negative 1 plus 2 squared plus 6. Okay, now I'm going to solve for a. I get 3 equals a times, what's negative 1 plus 2? Which is a positive 1 squared plus 6. Okay, what's 1 squared? It's just 1, right? So I can say y equals 1a, because 1 squared is just 1 times a, 1a, plus 6. Now I'm going to subtract 6. I'm left with negative 3 equals a. Okay, so that's negative 1 or negative 3 equals a. Now I can plug it in to my final equation. Y equals negative 3 times x plus 2 squared plus 6. Final answer. Okay, and then think about this. This makes sense. Well, where's my vertex? Left 2 plus 6. Okay, it's right there. Good. This negative. What's this negative do? It flips. So now we're working with this shape. Good. And then negative 3, the 3 makes it skinny. Make that 3 makes it skinnier. Oh, skinnier. Not skinny is. Skinnier. Okay? Next thing we're going to see is when we have two x coordinates and it goes through a point. So we're going to have two x coordinates and it's going to go through a point. We're going to work with this equation. Y equals a times x minus p times x minus q. And I want to start here so we know what we're talking about. We have two x coordinates, okay, and a point that it goes through. We don't know the vertex. We don't know the vertex yet. So let's go back here. Two x coordinates. Y equals a times x minus p times x minus q. Remember, when we were doing our x minus h, it was the opposite, right? If our x coordinate was positive 6, then our x coordinate was x minus 6, right? Same goes here. So we have, let's see, we have coordinates, our x coordinates are 6 and negative 8. And negative 8, and they go through the point 2, 7. Remember our equation: y equals a, right? Y equals a times x minus p times x minus q. And we have positive 6, so we're going to say y equals a times x minus 6. Okay, and then negative 8. Remember, when we say negative 8, we have to have plus 8. Now we're going to take these coordinates, x and y, 2, 7. So 7 equals a times 2 minus 6 times 2 plus 8. And now we have to solve for a. Remember, we do what's inside parentheses first. So 2 minus 6, that's going to give me negative 4. And then 2 plus 8 is going to give me 10. Okay, now we multiply. What's negative 4 times 10? It's a times negative 40. Okay. Now, how do I solve for a? I'm just going to divide by negative 40. And I should get negative 7 over 40 is equal to A. What's my new equation? Plug it in right here. I should get y equals negative 7 over 40 times x minus 6 times x plus 8. Okay, let's try one more. Let's try this final example. Okay, remember our equation. Y equals A times x minus p times x minus q. Alright, we know our x-coordinates. Our x-coordinates are negative 1, 0, so we can say y equals A times, that's negative 1, so x plus 1. Another x-coordinate is x minus 2, so, or positive 2, 0, so we're going to say minus 2. Alright, now what's my y or what's my coordinates? Right here, remember x and y, so negative 2 is y equals A times x is 1 plus 1, and then x is 1 again, okay, minus 2. Okay, so all we did was plug in our x and y. Now solve for A. Doing some math here, 1 plus 1 is 2, so we're going to get 2 times 1 minus 2, which is negative 1, equals negative 2. Okay, what's 2 times negative 1? We get A times negative 2 equals negative 2. Divide by negative 2 on both sides, we'll get 1 is equal to A. So, our final equation, if 1 is A, we're going to plug it back into this equation, so we get y equals, if A equals 1, do I even have to write it? No, because anything times 1 is just itself. So x plus 1 times x minus 2. There is my final answer. And that is it.